Hello everyone, I'm going to explain you how we find out the residence time in continuous state tank reactor using HYSYS. Before that, I want to explain you a problem that I will work in HYSYS. This problem is basically the lab tutorials that process engineering students are doing tomorrow. So it says that consider the following liquid phase reactor in an isothermal CSTR. A plus B gives you C plus D, where we have A as the ethanol, B is the diethylamine, C is the water, and D is the triethylamine, which is the product along with water. The inlet flow rate is 50 kilomole per hour for ethanol, 50 kilomole per hour for diethylamine, and 100 kilomole per hour for water. The reaction is second order with respect to ethanol. Means to say the order of the reaction is 2, and this is the rate of the reaction, where the K is basically the rate constant, and A is the constant for frequency of particle collisions, and E is the activation energy, R is the general gas constant, and T is the absolute temperature. So we have these values available in the question. It is saying that if the reactor volume is 4440.8 liter, what percent conversion of ethanol will be achieved? So our objective is we can find out what is the percentage conversion of ethanol, and I will also show you how we calculate the residence time in this example. Now this is the solution. If you want to read this, I have developed this solution. However, I will take you and explain you in the video step by step. So let's go to the HYSYS and identify these components there. So this is my HYSYS. I open the new case. So let's see the components one more time. My components are ethanol, diethylamine, water, and triethylamine. So I go here and click on go to the component list and click on add, and now start entering their names. Ethanol, hit enter. The next component was diethylamine. The next component was water here, and our last component is triethylamine. So we have added our components which are reactants and products both. The next is we need to choose our fluid package. For this problem we will choose NRTL because that is most suitable for such kind of system. So I choose my NRTL. HYSYS is okay with that. And the next is, because it is a chemical reaction, I need to provide some reactions in my properties tab as well. So you click on the reaction and you click on add, and here you need to click on add reaction. Now these are the different types of the reactions based on the given problem. For now we are dealing with the kinetic reaction. I click on the kinetic and click on add reaction. You can see that it has added a reaction for me in the back, and now I can close this window and double click on this. I still need to provide what are the reactants and products and what are the parameters for rate equation. So with this window, just drop down and select all your components one by one. We have water and we have triethylamine. Now over here in the stoichiometric coefficients, we need to provide either it is a reactant or it is a product. So let's go to our problem statement again. So ethanol and diethylamine, these are the reactants. So I need to add negative as their coefficients, whereas the water and triethylamine are the products. so I will add positive 1 for their coefficients. So let's go back here. So for ethanol, as I mentioned, it is a reactant. I enter -1. Diethyl amine, it is a reactant. I enter -1. And the water is a product. I enter +1. And this is my product as well. I enter +1. You don't need to press plus here, but just to be in my mind that I'm entering my products, I always like to press a plus before entering a 1 here. Now in my statement here, it is saying that this reaction, it is a second order reaction with respect to ethanol. How do you convey this message to HYSYS? You go here. Now look at this one. This is a irreversible second order reaction. So with respect to the ethanol, so here you just enter your 2 and the rest of your values will be 0 in the column. Similarly, because it's a forward order reaction, not a reversible, so I can make all entries zeros. By default, the products in HYSYS reaction will have the positive ones for their reverse order, so we can make them 0 because they are not needed to us. Now second thing, you need to make sure you have ethanol as a base component, because I showed you in our example that it is second order with respect to ethanol. So here I need to make sure that ethanol is chosen. If you have any other product, you just need to change it and bring your ethanol here. In the next one, you need to change these units. The basis units should be in terms of gram mole per liter, and the rate units should be gram mole per liter per hour. In the next step, we need to provide the values for A and E. So let's go back to our question statement again. The value of the A here is 4775. So here I can enter 4775, and the value of the E, it is also given to you. It is 10,000 joule per mole, and I go here, I enter 10,000 here. 10,000, it is joule per mole, and this is my joule per mole. Now as you can see that HYSYS has given me a green signal here that everything is okay with my reaction, and now I can close this window. However, one of the important steps before we move to the simulation is we need to attach this reaction to our fluid package. How we do that? Just click on add to the fluid package, select this, and click on add set to fluid package. Now as you can see that I have the signal here. This means I have attached my fluid package to the reactors. And now let's look on the left hand side. This arrow means this component list is good, fluid package is good, and it is a chemical reaction, so I have defined the reaction as well. Now I can enter into my simulation environment. Click on simulation, and here we are in our simulation environment. We are working with the CSTR. I will make some more videos for other reactors. So let's go to the reactor tab, and from object palette, bring your reactor into the simulation. Now I can close this and double click on this reactor. Here we need to provide the properties associated with the design of the reactor. So my inlet stream, let's say I give it a name of feed. There are two outlets here. We have the vapor and the liquid. Let's say for the vapor I write down gas product. We don't have any vapor product in this chemical reaction, so the composition will be 0 for gas product, but we still need to provide the connection here. And this one will be your liquid product. And we also need to provide a heat energy stream, because this is an isothermal reaction. By that I meant to say the temperature of the reactant is the same as the temperature of the product, but we still need to provide our energy. So we have defined our connections here. The next step is you go to your rating here, and here you provide the volume of your reactor, and this is given in our question statement that the volume of the reactor is 4440.8 liter. So I just go here and 4440.8 liter, and HYSYS will automatically calculate your diameter and height of your reactor if your solver is on the active mode. And you can also choose the orientation for this. If it is an horizontal CSTR, you will see that it will calculate the diameter and the length. For the vertical, it is calculating the height and the diameter for the same volume. So I will keep it as a vertical orientation for the reactor, and then we need to go to our next step. In our next step, we need to provide the reaction. As you can see that HYSYS is asking us the reaction set. So you go to the reaction, and how do you add a reaction here? Just go to the drop down menu and click on the name of the reaction set, which is set 1 in my case. And you can see that HYSYS has brought all the reactants and products into my simulation here. This is one of the important steps when you are dealing with the chemical reactions in reactors designing. In the next step, we need to provide our data for the input, and this is my feed here. If you recall from our example here, my temperature is 50 degrees Celsius and my pressure is 354.5 kilopascal. So let's go here. My temperature is 50 degrees Celsius and my pressure is 354.5 kilopascal. And the molar flow, which is given in your statement, for this one is we have 100 plus 50 plus 50, which makes it 200 kilomole per hour. So this will be my 200 kilomole per hour. The last step is we need to add our composition here. Now if you go on statement again, from this one we can calculate what could be the composition for this. It will be 50 divided by 200, which will be 0.25. For ethanol, 50 divided by 200, which is 0.25 for diethylamine, and 100 divided by 200, which will be 0.5 for water. So that's what we are going to enter here. So for ethanol, my composition is 0.25. For diethanol, my composition is 0.25. Diethylamine, and the water composition is 0.5, and the composition of triethylamine is 0 here. And then you click on normalize and click on OK. Now we have defined our composition here, and for the product stream we only need to provide our temperature because it is an isothermal reaction, and temperature for the liquid product. So my temperature will be 50 degrees Celsius. Now as you can see that HYSYS has converged my CSTR. So let me close this and take you to simulation here. So this is my HYSYS which has been converged when I provided all the required information to it. And now we can study the results here. Double click your CSTR and go to the reactions tab here and go to your results here. So this is my percentage conversion based on my ethanol, and that's what was asked in our objective. What percentage conversion of the ethanol will be achieved? So this will be 91.44%. So this is my answer here. And the reaction extended 45.72 kilomole per hour. And now I can show you how we calculate the residence time. In order to calculate the residence time, you need to develop a spreadsheet in HYSYS. How we do that? Just go to the flow sheets again and click on models and streams and bring your model palette again. And here is the spreadsheet, as you can see. Bring it into the solver. Let me close this and double click this. Now in this spreadsheet, you don't make any changes in this one, but only on the spreadsheet. Now this spreadsheet is the same as you use in the Microsoft Excel. So in the first column, let's type in the reactor volume. The next type in the liquid flow rate. And the next is the residence time, which is basically the ratio of the reactor volume to the liquid flow rate. Here we need to provide the values which are in HYSYS, not entering manually. So how you do that? Right click here and click on add import variables, and here click on the CSTR, the name of your reactor, and we need to find out what is the tank volume. This is the nomenclature that HYSYS use for the reactor volume. So as you can see that this is my tank volume. Select this, add it, and click on done. Now this is the same volume. If you recall, we have it before. We can even verify this. How we can do that? Just double click on this and go to the design tab. Go to the rating tabs, and this is here the same volume as we have before. So this is 4.441 cubic meter, and this is 4.441 cubic meter. So this means this is good. Now you can close this for CSTR, and let's come back here. So in terms of the liquid flow rate, we are looking for the product again. Right click this and add import variables. Here we are looking for the liquid product, and we are looking for the actual volume flow. This is what we are looking for. Just click this and click on this arrow, add this, and click on done. Now HYSYS has brought this liquid flow rate. Before I go to the next step, just note down here, there is a blue and the black colors here. In HYSYS, the blue means you can modify this value, whereas the black means these are calculated by HYSYS. We cannot modify them at all. Now let's go to the residence time. Residence time is the ratio of your reactor volume to the liquid flow rate, as I mentioned you. And you can use this this spreadsheet as you are using your Microsoft Excel. However, when you enter the formula, you need to type in the address of the cell itself. You cannot just click it there. By that I meant to say, let's say I want to divide this B1 to the B2. Let's say click here, and if I click on B1, it will give me an error. So this means I cannot assign the cells like I do in Microsoft Excel. What you can do, just click on equal sign and type in your B1. HYSYS will adopt that value of the cell, which is 4.441, and divide it by the liquid flow rate value, which is present in B2 cell, and now hit enter. So my answer for the residence time is 0.4609. For the units, because both of them are in terms of the volumes, and according to my liquid flow rate, it is being recorded in terms of hour. So my units for the residence times are hours. So I can say that the residence time for this CSTR, continuous state tank reactor, is 0.4609 hours. You can also convert this into the minutes. What you need to do, you just need to multiply this value by 60. and normally we report the residence times in CSTRs based on the minutes. So I can say that the residence time for this continuous state tank reactor is 27.65 minutes. And again, this is blue because this value is dependent upon the reactor volume, which I can alter myself. In some other videos, I will show you how we can specify this reactor volume based on the reaction conversion. For example, if you want to have 100% reaction conversion, what will be the volume of your reactor required? So I hope this helps. If you have any questions, you can email me. Thank you.